youngsters, this is Mrs. Vanderlei bringing you 14.8 Blankwalle. This is part 2. Now, if you're thinking from part 1, like, holy cow, this is going to be crazy that you need to have the quadratic formula on your phone all the time, the answer is no, you really don't. Most cases, you will not need the quadratic equation. There is a simpler way. Okay, this is probably what you're going to see on the AP test. I don't ever recall seeing any quadratic equation on the AP. So really get to know what I'm going to start here today. So this is simplifying approximations and working equilibrium problems. And there are really 3 hints to look at. Number 1 is look for very small values of k. Rule of thumb, now what do you know about rule of thumb? It's not 100% correct, but it's something to look for, all right? If k is less than 10 to the negative 5th, okay, you might hear me say, oh, ich bin sehr fröhlich, all right? And that means in German, I'm very happy, because your life gets so much easier when the k is really small. And what happens when k is that small, your x, when you subtract x out, may become negligible. You don't worry about that x factor, haha. And so your math gets a lot easier. So in the E line of the ICE table, you can actually drop that minus x part from the values, and then in your law of mass action, you don't put in the minus x, okay? What you do use, though, is the x for the value that started out as probably 0, okay? So keep that x in. Now, after you solve for x, you need to go back and check to see if it is greater than 5% of the initial value. This is called the 5% rule. If your x value is bigger than 5% of the initial value, then you got to go back and do the quadratic equation. And then you might hear me say, ich bin nicht fröhlich. That means I am not happy, because now you have extra work, all right? So does this happen very often? No. But can it? Yes. Okay. So keep that in mind too. And finally, if there are any initial concentrations that are 0, then Q does not have to be calculated. It's just going to go towards the area that has 0. Q, again, is very helpful in doing all these problems, so you know how to set up your ICE table, okay? So let's kind of see what's going to happen next. So here's a general equation, and look at that k value, 3.3 times 10 to the negative 5th. So what am I going to say? Ich bin sehr fröhlich, all right, because probably we're going to be able to drop the x value. So what do I mean by that? Well, here's my ICE table. I start out with 1 molar of A, 0 molar B. It's going to go to the right because I have a 0 in the B part. So minus x plus 2x, and E is 1.0 minus x. So what does this simplification do for us? We can actually cross out that x here. So when we actually do the law of mass action, you don't even need to include the 1.0 minus x, you just put in your 1.0. So let's see how we do this. Here is my law of mass action. Please do not be lazy. Always write it out like this first. And then your next step is to substitute. Look at what I did here. Notice that this is now just 1, not 1 minus x. Our life gets so much easier. There's no quadratic equation now. So if I multiply both sides by 1, well, guess what I get? Quantity 2x quantity squared equals 3.3 times 10 to the negative 5th. So I went ahead and squared it. This should be 4x squared. My 2 didn't make it as a exponent there. Neither did my negative 5. What happened? So anyway, 4x squared equals 3.3 times 10 to the negative 5th. Divide by side by 4. And then take the square root. Okay, so what do I do now? The question now becomes, is my answer 5%, or is the 5% rule work? So what you do is take 5% of your initial value. So 5% of 1 is, hopefully you got this, 0.05. My answer over here is less than 0.05, okay? So the 5% rule works. So I don't have to go back and figure out anything. So once again, what am I going to say? Ik ben zeer vrolijk. All right, see how easy the math was when you compared it to what we did in the prior two problems? That's what the simplification does. So last but not least, we need to go back and figure out what the values of A and B are. Here we go. So what is 1 minus 0.00287? It's right here. What is B? It's 2 times 0.00287, and it is right here. Okay, if you go back and plug these values in, and just to double check, make sure they do make that K value that we came up with, 3.3 times 10 negative fifth, and you'll see it works out great. Notice that the K value is small, so it does not favor the products. I don't make that many products. Look, it's like 5 thousandths of a molar, and A did not decrease by much at all. So that's how that one's going to work. So let's look at problem number 28. Now, folks, I have my handwriting. I didn't type this out. It takes a long time to do that, so I'm trying to get this finished for you. So problem number 28 is another equilibrium setup. Look at the K value and look at the exponent, 10 to the negative 7. Does that fit my requirement to make it the simple way? And the answer is, oh, yes. So I can use the shorthand. Now, notice something else right here. You're using a 5-liter vessel and 0.0125 moles. Folks, what goes in a ice table, it isn't moles, it is molarity. So we can all start singing our song, The Moles on Top of the Mountain. Make sure you know to put molarity in the ice table. So when I do the ice table, you notice what I get here. Where did my 0.0125 go? Well, I converted moles into molarity. And then again, I have minus 2x plus x. And then notice, what can I do to this 2x here? When I go 0.025 minus 2x, I can cross it out. Why? Because my value up here is quite large. Now, what you can do from here, why don't you pause this and set up the law of mass action, plug in your values, but instead of the 0.025 minus 2x in your denominator, you're only going to put the 0.025, don't forget to square it. Okay, so let's see how you do. Pause this, and then we'll be back. So here are our terms, and I didn't mean to really cross out the H2S here. I just meant that the X value is canceled. So I still put the 0.025 in here, and don't forget to square it. So then it still is equal to the 1.67 times 10 to the negative 7. When I go ahead and do my math, hopefully you'll get the same answer as I do. So multiply both sides by 0.025 squared, and you end up getting 1.04 times 10 to the negative 10th on the right-hand side. And then when you work with this, we have 2x quantity squared, which is 4x squared, times x is 4x cubed. So now divide both sides by 4, and you get x cubed equals 2.61 times 10 to the negative 11th. X equals 2.97 times 10 to the negative 4th. I hope you got something along those lines. Now, what do you do with those values? In your calculator, I didn't show it here on the board, but see if you can do it. So what is 5% of 0.025? So 0.025 times 0.05 is 0.00125. So 5% of this number right here is 0.00125. Well, what do you think? Is that number bigger than my x value? Yes, it is. So that means phew, ik ben zeer vrolijk nog eenmaal, which means again, all right? So I passed both tests. My k value is small, and my x is less than 5% of my initial value. So now it's a matter of going back and plugging in the x. So I don't need to worry about 2 times this number, and you get still 0.025. 2 times this value here is 5.94 times 10 to the negative fourth, and then this value is 2.97 times 10 to the negative fourth. You know, what might not be a bad idea, just to prove to yourself that this is, you know, worthwhile. If you went ahead and took 0.025 minus 2 times this number, what are you going to get? So 0.025 minus 0.00059, I get 0.0244, which is awfully close to 0.025. So it really didn't change that value by much at all. And so I am convinced that we did the right thing. How's that? So now what? We have the exact same setup, same equation, same temperature, same Kc, but what changed this time? Well, what changed was how many moles I have. My initial concentration went way down. Okay, I still have to convert it to molarity, but watch what happens here. Okay, so here is my ICE table. I am so happy because my K value is so small that I went ahead and I canceled out the minus 0.2, minus 2x. Notice that here this is my molarity, not my moles. These are the same. So what's going to happen next? Go through all the math, all right, and see how what value you get. Well, here's my math, okay. Plugging my values again and solving for x, and this time I got x is equal to 1.38 times 10 to the negative fifth. Now take your 5% rule, and 5% of 0.00025. Go ahead and get your calculators. So 0.00025 times 0.05 is 1.25 times 10 to the negative fifth. I get 1.38 times 10 to the negative fifth. So what just happened here, my x value is greater than the 5% rule that I initially started. So what do you think I'm going to say here? Oh no, ich bin nicht fröhlich. I am so sad. So what does this mean? I would have to go back and do. Yeah, the quadratic again. So this would be a problem very similar to probably number 24 that we had earlier. I'm not going to go ahead and do that. You can if you want. I'm not going to, but I wanted to show you the 5% rule and how it didn't work in this case. And what else can we maybe draw from these first two problems? What changed so that it worked in the first case and didn't work in the second case? It was your initial concentration. So you got to be really careful when your initial concentrations are really small, like it is here. The 5% rule does not really work, so you got to be careful. If you have a larger molarity like we did up here, you have a greater chance that the 5% rule does work. Okay, so to save you your time. So if you're thinking ahead and if you use the K value, say yes, all right, then look at your initial value, and if it is pretty small, then think, ooh, I may have to go back and use a quadratic. Okay, so let's see what the next page is going to do for us. So problem number 30, for a generic equation, here you go, consider the value K and the initial concentration of A. In which set will the X is small approximation likely to apply? Okay, so think about, let me reword this question again. When will the simplification work? Okay, that's the same thing as saying X is small. So pause this, come up with a good answer, and let's see what we come up with. Okie dokes. So I'm looking for a value of K around 10 to the negative fifth, so that's A or C, and based on the one that we just did before, which is more likely to work out, a high initial concentration or a low initial concentration? Hopefully you remembered it was the high one, so A is going to be your answer. Now if you look, these are optional problems. I really would like you to do that so we have something to talk about next time we meet. So go ahead and do these. We will go over the answers and we'll see you later. So my final thoughts are, don't wait to be great. Have a good day.